group-based, but again, even a consistency group is a collection of volumes. And as with anything with storage, right, when we're talking about replication or snapshots, without any assist further up the stack, all that the storage can do is be what I call crash consistent. I need help to do application consistent snaps or an application consistent copy v replication. And when we get into some of the tools, we'll talk a little more about that. We're going to talk about RPO when we talk about replication, or recovery point objective. Essentially, the amount of time, the difference I can handle between my primary copy and my secondary copy. And then at the bottom, I've got question marks there, but it's not a question, right? The maximum number of volume mirrors on this technology is 1536, and I'll talk about how synchronous counts a little differently than asynchronous as we get into the differences within the two. I have a number of different configurations, and I apologize I didn't change all of the pictures. Most of the pictures are actually XIVs, but the first picture I changed to A9000, but it really doesn't change things what the picture is. But again, I can do a single way source to destination, seeing more and more of our customers do a simultaneous bidirection where I've got active workloads in the data center. I'm not saying an active solution, but I've got both data centers are doing some production work and some DR work. I can do one to many. I can do many to one. The only problem with doing many to one is I can really overload the catcher or the target with lots and lots of write data if I fan out too much. I do allow a fan out of 10 to 1, but again, you got to be really careful if you're architecting a solution with that many to one box, because we have a tendency to really overwhelm the destination, and then more importantly, probably can't handle the workload requirements if we declare a disaster and have to run all of those workloads from one machine. So again, the granularity is a volume or a consistency group, which is, again, a set of volumes. And essentially, pretty much anything I can do with a volume mirror, I can do between a mirrored consistency group. And we'll talk a little bit more about how we set that up in subsequent slides. So there's source, which is typically production. There's destination, which is typically the remote site. Sometimes I'll use primary and secondary. That is synonymous with primary as the source and secondary as the destination. Sometimes I use source and target, but I'll try to stick with primary and subordinate or source and destination for clarity purposes. So focusing on synchronous, so the value of synchronous is that I have a 0 RPO, meaning I'm going to guarantee that the writes are in both boxes, the write data are in both boxes before I acknowledge the host. Standard distance is 100 kilometers. We can go longer. Really, the only thing that's affecting that is the ability of the application to deal with the additional latency that we have, because again, we're moving the data from the primary to the secondary or source to the destination, and that takes longer if they're further apart. Advantages, again, 0 RPO, but I am impacted by latency as I increase the distance between the source and the destination. I can use on the A9000, I can use either fiber channel or iSCSI ports for connectivity. We are seeing, in general, across the family, right, that's XIV and A9, we are seeing a large number of customers using fiber channel for host connectivity and then using the iSCSI, the built-in iSCSI, for replication connectivity. I do have some customers that are still doing FCIP and some that are have dedicated bandwidth between sites. But kind of the best practices, I want to go from I want to create a connection between at least two modules, two grid controllers, And I do want to do that from, again, ports 2 and 4. So, again, ports 1 and 3, we typically reserve for host connectivity. Ports 2 and 4 are typically reserved for replication or migration connectivity. And, again, I want to go from Module 2 to Module 2, Module 1 to Module 1. I don't have to do that, but it's just a best practice to do that. It helps with keeping things straight a little bit. And I want to go from the initiator port on one module to the target port of the other. And again, the default initiator port in every module is port 4. And then if I'm doing iSCSI, I don't have I need one connection between each module because I don't have a separate connection for an initiator. I can initiate traffic from either side over an iSCSI link. So I only need one link between modules. Again, I need a link between multiple modules, so I have redundancy in my communication between the boxes. And I do support up to 9,000 MTU for the iSCSI connectivity, and my bandwidth is same if it's dedicated, but I go up a little bit for my minimum connectivity if it's shared over fiber channel, because we typically see more traffic, more types of traffic as well on a shared Ethernet or iSCSI connection as we do over a shared fiber channel connection. So how to define a synchronous mirror? Right? I have to have a mirrored volume. So I select the volume on the production system with the source, and I select the volume on the target, and then I can choose to activate at creation or activate later. For a consistency group, I need to have active mirrored volumes, so the volumes are already mirrored to another volume on another box. I'm going to create that consistency group at the site or the production system. And then I'm going to create a consistency group at the destination. I'm actually going to then create mirroring between the two consistency groups. That completes initialization very, very rapidly because there's really no data being sent, but there is some coordination being done between the two boxes. And then I can add mirrored volumes into that mirror consistency group. I can also take mirrored volumes away from that consistency group at any time. But I create the mirror between the consistency groups, and then I add volumes that are already mirrored into the consistency group. Number of states for synchronous mirror inactive. I'm not moving data. Initialization is I'm trying to get the primary and the secondary volume to be the same, and they're not. And while I'm in the initialization stage, the secondary or the destination volume is kind of in the fuzzy state because I'm not exactly sure where it is. I'm not sure it's an actual copy of the primary until I'm done with synchronization and I'm done with initialization and moving to the synchronized state. I do offer the option of an offline init both in synchronous and asynchronous replication. And that means that at some point in time, the volumes were the same. And I've had this, we call this truck mode. And I've had customers do it one of two ways. I've had customers do a backup of a volume and move that backup media to the secondary and restore it. I've actually had customers put the two, this is the case of XIV, I put two XIVs next to each other, did a synchronous replication, broke the replication, put the box on the truck, moved the truck to the data center, and then reestablished the relationship via offline initialization. What offline initialization does is it does a checksum of every 64K and just confirms that the checksum is the same. And if the checksum is the same, then I don't send data. If the checksum doesn't match, then I send that 64K of data. So you can save a significant amount of data transmission based on, again, kind of how much I'm writing to the primary volume and how long they've been separated, how long time it's had to drift apart. But I do offer the offline init in both sync and async. So during initialization, the host I/O goes, again, one, I'm doing an asynchronous copy of all the data from the source to the destination. When I do a write to the source from the application server, I'm going to put that in cache in 3 different modules, and I'm going to acknowledge those. So I do not have the distance penalty while the relationship is in the initialization stage. It's only when I go to the synchronous operation and I've got the 2 in sync, I'm going to keep them in sync, but I then have the excuse me, I then have the additional latency to the distance. And what happens is it writes to the host, then the source writes to the destination acknowledges that it gets it, and then the source acknowledges the host. So I now get that data transfer time from source to destination that it's going to affect the latency that the application sees. So for an unplanned failure when I'm running synchronous replication, I'm going to do a change roll, and what that does is that takes what used to be the destination, makes him the source, inactivates the replication relationship, and I can run production off of my new source. Now I am tracking differences between the source and what will become the destination. I am tracking differences. So when I'm able finally to fix site 1 or fix the link or fix whatever caused me to do this change roll in the first place, then I actually do a change roll of tier 1. It changes it from source to destination. I actually change it to target, and then I resync and get the both volumes to be the same. And then once that is done, then I would then bring down my production server, make sure that I get some time to do some replication, make sure I catch up any last-second changes that come from flushing cache as I'm bringing the server down. And then I would go ahead and do a change roll. I went the wrong way. The switch roll, and then that will allow me, then that, what that does is that the switch roll assumes that both boxes are up, that the link is up, and that just automatically changes the destination and the source on both sides. So I bring again, my server's going to be down, I do the switch roll, and I'm going to bring my production servers back up at my production site, and then I'll be okay. Then I'll be replicating again from my source to the destination, again from my primary site to my disaster recovery site. So that's kind of the quick, easy steps of going through an unplanned failure all the way through back to doing the failback and coming home again. Again, just 4 steps there. I have the ability to do additional copy at the remote side. I can do as many snaps as I want of that volume. I also have the ability to do a mirrored snap, which means I issue a command and I'll get a snapshot on both sites that's guaranteed to be consistent at a point in time. So then I can have the ability to do testing, DR testing or other testing on copies that are exactly the same at both locations. So that's it for synchronous. Async is a little bit different. Async is, again, I'm going to have an RPO associated, excuse me, with async. And that is going to be based on what, again, the time value of the data and how far apart I can afford to have my source be from my destination. It can be unique per volume or consistency group, and that can be because of different service levels. It can be because I'm doing bandwidth management. Typically, not all of the data I'm replicating is of the same importance, so having the ability to set RPOs differently, again, allows us to then help the box manage the bandwidth. The system is going to manage to the specified RPO. It also has kind of tracks amongst all the different groups how far away from the desired RPO each one is. So you can think of it as, without specifying a time, it's RPO is great, RPO is good, RPO is what it's set to, RPO is a little bit lagging, RPO is lagging a lot, and RPO really, really stinks. So there are multiple levels that the Foxconn managers internally, and what we'll actually do is if it has a group, a volume, or a consistency group that is falling further behind because there's not enough bandwidth and I'm doing a lot of write activity, it will actually help, it will actually give more resources to the groups that are really, really far behind and try to manage everybody to be the same amount of behind. If there's, again, if there's not sufficient bandwidth to keep everybody up to at RPO okay, it will help to try to manage everybody so that the same sort of lagging, as opposed to having two, some groups that are RPO okay and just a few groups that have really bad RPO. It will manage resources and manage bandwidth amongst the different groups to try to level that out. And we do get events for RPO lagging and RPO okay, and then we can look at thresholds based on the % increase in the RPO or the absolute increase in the RPO. So for defining an asynchronous mirror, I'm going to, again, same sort of steps. I'm going to have a volume at my production site, at my primary resource. I'm going to select that volume where it's going to. I'm going to select the RPO. We have this thing, two concepts, right? I have an interval and I have an RPO. And the desire is to have at least two intervals within an RPO. So if my RPO is a minute, I would want my interval to be 20 seconds. All right, that would give me two or more intervals inside an RPO. Now, if you set things up using the GUI, it automatically picks the interval. If you set things up using the CLI, you have the opportunity to set the interval. Now, you can change the interval through the GUI as well, but it will pick one by default, whereas if you're doing the CLI, you have to set one in there yourself. Again, same thing for consistency groups. I have to create the groups and create the mirroring, and then add mirrored volumes to the consistency group. So the asynchronous replication is based on the snapshot technology. So I'm going to, when I start my initialization, I take a snapshot at the source. I call it the most recent snapshot. I then move that. I use a job called a sync job to move that information in that most recent snapshot down to the destination. Once I've done that, I take a last replicated snapshot. And then what I'll end up doing is I will end up repeating this process. All right, so then once I have the last replicated at the remote, I change the name of the most recent to the last replicated, and then every interval, I'm going to repeat that process. I'll take a snapshot, call it the most recent. I will then calculate the difference between the most recent and the last replicated, send those differences down the wire, and then once that's done, I will rename I'll overwrite the last replicated snapshot with a new snapshot of the volume, and I will rename the most recent to last replicated and delete last replicated. So in a synchronous relationship, my recovery point is the volume itself, because the primary and secondary are always in sync. For asynchronous, our recovery point is actually the snapshot, because the destination or the remote volume is in an indeterminate state. Because when I calculate the differences between the most recent and the last replicated, I do those in byte order, not write order. So until I get that whole set of differences down to the remote volume, that volume is in indeterminate state, which is why the recovery point is always the last replicated snapshot and not the volume itself. So offline initialization, again, my production is, and my destination volumes used to be the same. All right, so I'm going to take a snap of that source volume, use it for offline init. I'm going to back it up, right, and I'm going to move it, restore it, and then go ahead and create my async mirroring specifying the offline init again. I'll start doing checksum on the 64K boundary, only moving the data that has changed. That doesn't have the same checksum. And again, I've had customers do it both ways: put some media and ship it to the remote site, or put the data on the storage and ship the storage to the remote site. Either one works, because again, all I need for offline it to work is for that content of that volume to have been the same at some point in time. And again, you don't want to take too long to do this, because depending on the right activity on that primary, I may be very, very different and not saving a lot by doing it if I take too long to do the restore on the destination side and then do the offline init. And I'm going to activate the async mirror once I've done all these steps. So really, this is used when I've got lots of data at a lower change rate, or I've got limited bandwidth between the sites, and it's just easier to get the initial dump of data done via another means, and then only track the differences. And I can use this for other things too, right? I can use this to change from sync to async without doing a full copy. I can also change my volume size without doing a full copy. I have to make sure I change the volume size to the same size on both sides of the relationship. Now, this is not true of synchronous. Synchronous, I can go into and change the primary volume. I can make it larger while I'm doing synchronous replication. Because again, I'm pretty much confident that my primary and my secondary volumes are going to be the same. In async, I don't have that same confidence. So I have to stop the replication, resize the volumes, reinitialize the relationship with using offline init, and then restart replication. Just because of the nature of async. Now, the benefit of that is I can have this thing halfway around the world. And I don't have a latency penalty for doing I/O because I'm handling the data changes asynchronously to the host I/O. So again, normal operation. I have my application server. I write to the local XIV or A9000, as the case may be. You guys can tell where these charts came from. Then I acknowledge the application. Then every interval, or by command, I take a snapshot of the source. Right, that's my most recent snap. Calculate the differences. Send those to the destination. Overwrite the last replicated with a new snapshot. Notify the primary. Then again, it deletes the last replicated and renames most recent to last replicated. So my recovery point is always this last replicated snapshot, and the box makes sure that the last replicated snapshot is always the same between the two boxes. Now, if I want to do a DR test, I probably just want to duplicate the last replicated snapshot and do my DR test on a duplicate of the snapshot. I have an unplanned failure. Again, I'm going to do a change roll at site 2. That's going to do a recovery of that last replicated snapshot to the volume. Because again, I don't know what state that volume is in based on, I could have had an active sync job at the time I had to declare the disaster. So my recovery point is always that last replicated snapshot. I then start running my production on the new source, and then do a failback. I'm going to go ahead and do the change roll at the what is now the destination, what used to be the source. And now I start replicating back in the other direction. I'm going to take a most recent, calculate the differences, send those over to the destination. When I'm to the point where I'm RPO okay, again, RPO lagging, then I can go ahead and do pretty much the same process I did. I'm going to bring my server down. I'm going to force another sync job to occur. Let me go back. Let me catch up right. Then I'm going to do a switch roll, and that's going to set things back the way they used to be, and then I can bring my production server back up on the source. Again, there's the summary of those. So in both cases, it's a change roll, switch roll. All right, so the switch roll assumes that both boxes are up, they're talking to each other, the copy is consistent. So either I'm an RPO okay, or I'm actually at a synchronized state for synchronous, and then I can do the switch roll, which instantaneously changes both rolls. It changes the destination to the source and the source to the destination. Again, I typically use switch roll when I'm doing my fail back, and I use my change rolls as I'm doing my fail over. I can also create a mirrored snapshot in an async relationship. And one of the things we have customers sometimes do is, again, from a storage perspective, anything I do for that snapshot related is crash consistent only. So I need help further up the stack. I need to freeze the application, I need to flush the cache, and then force a sync job in an async case, or allow the writes to clear in a synchronous case to get an application consistent snapshot or an application consistent copy. So I can use this mirrored snapshot to do that on a manual schedule to make sure that, so I just let my replication run. For the most part, I'm okay with crash consistent copy, but once a day I want to have an application consistent copy. So I've got a cleaner recovery point if I choose to use it, and that's what the mirrored snapshot would be used for. Sync and async can coexist, so I can have. It doesn't really matter. The relationship is between the volume group or the consistency group, not really a relationship between the boxes. Now, there is a slight difference there. If I'm using, like the bottom case here, I've got the same box doing sync and async. I can only set the target parameters for a box to be one set of target parameters. And basically the target parameters are the ability to set the resync rate, the initialization rate, and the resync rate. So I can control how fast I want to initialize, meaning move the data the first time down the wire to the box. I can also control the resync rate, which is the case of I have got to get those volumes back in sync because for whatever reason the line went down or other reasons the copies are no longer in sync. I can have a different resync rate than I have an initialization rate. I can set that on a per target basis. So again, some of the benefits of replication, it's no additional charge. The XIV, the A9000 licensing is such that customer buys the box, it gets everything the box does with no additional licensing. I can have a large number of consistency groups. Again, it's pretty easy to manage via the hyperscale manager. I have a full CLI, so I can run scripts with the CLI, and I can specify those initialization and resync rates. So I'm going to pause there for a second and ask if there are any questions about replication.
Yes, this is Keith. I got a quick question, Steve.
Go ahead.
You were mentioning that when you change the role to Site 2 from destination to source, that you should map the server to the LUN. So my question is, can I go ahead and pre-map all of the LUNs to the server like I have in SVC now, so I'm ready in case of a DR event?
Depends on the server, because they're locked, so they're read-only.
Because right now, all the DR servers are mapped to the DR LUNs that I replicate with SVC. So
okay.
If there's a test or a real DR, I go into Copy Service Manager, I initiate a flash, and they're ready to be presented to the DR host.
Yeah, so I don't know whether SVC has those targets in read-only mode or not. I know they are on the A9000. That'd be the only caveat. If the host is okay with, now, can I do it in the A9000? Absolutely, yes. But if the host is actually up and seeing a read-only volume, that's a host question that that's going to vary based on operating systems. Does that make sense?
Right, and then typically at the DR, they have dual-port HBAs. One set of HBAs is for their test dev, and then they reboot the servers to bring them up on the other ones for the DR.
That makes sense then. Then we should be okay.
Okay, thanks.
All right, no other questions. I'm going to go ahead and keep moving forward. Talk a little about data migration. So I have the ability in the 9000, in the XIV as well, to essentially have the box act as a Linux host to pretty much any legacy storage, Fiber Channel or iSCSI, and then basically take the information off of the legacy storage and bring it onto itself, while it's also serving IOs from the host. Again, and we mentioned that initiator port, that's port 4, so I can use that initiator port, map that again as the storage sees a Linux host. So again, the A9000 acts as a host of legacy storage. It presents a migration volume to the application server. I copy the data as a background process. Now it is a single pass process. So as we talk about the mechanics of doing this, it's very important when we disconnect the server from the legacy storage that we make sure we are completely disconnected. Because if there is a path for that server to get to the old storage and it issues a write down that path, and I've already passed, let's say I'm copying LBA 100 and it writes to LBA 90, the XIV, the A9000, will never go back and pick that up. It is a single pass, 0 to N read pass of the volume. So it's very important that we make sure we don't have any pass for the server to the legacy storage, or data corruption could result. I say it's transparent to users. There is a thing we have to be careful of. Typically when I'm migrating from older storage to newer storage. And in the case of the 9000, right, I got very, very capable box there of pulling data off it. Lots of horsepower in the grid controllers. So it is possible to overwhelm the legacy storage with read requests from the A9000, and I can create issues for production I/O that's still running on the legacy storage. So my best practice is to always start small, start at a very low number, 50 megabytes a second or something small like that. I can change it in real time, and I'd rather start slow and then ramp up than start too fast and affect production. Because again, typically I migrate pieces off at a time. I'm not going to migrate the whole workload from a legacy array onto an A9000 all at once. Just want to be very careful I don't swamp the box and cause problems for the remaining production workload that is running on that legacy storage. So a read request is going to be come like this, right? The application server is going to request a read. If the data has already been copied from the legacy storage to the A9, it just returns it. If it's not, if it hasn't been, it then takes and proxies that read request down to the legacy storage and then returns it to the application server. So once I've got this set up, I can actually, and I'll show you that I think the next slide or two, I can power up the host. I can be running production workloads while the 9000 is pulling data off of the legacy storage, because if it's not there yet, I just again proxy that read down and bring the data back up. So for a write request, while I'm doing this, I've got a mistake here, right? It should be 3 modules, not 2. That's right, I'll fix that. So again, I write to the A9000. So I have 2 options on the migration. I can specify to keep the legacy updated or not. And essentially, if I've specified to keep the legacy updated, then I take that write information, I write it down to the legacy storage, get the acknowledgement from the legacy storage, and then I acknowledge the host. So I've essentially created synchronous replication between the A9000 and the legacy storage. And you probably don't want to plan on keeping it that way. It's not designed as a long-term, synchronous solution between non-like products, but essentially that's what it's doing, is creating a synchronous relationship for that volume between the A9000 and the legacy storage. So if you're doing this over distance, you certainly want it to be within metro distance. You don't want to be beyond the, because that would again add a sufficient additional latency that it would probably cause problems for the application server. So here are the kind of the steps. All right, so the server is first connected to the legacy storage. Obviously, I want to get a good backup. I want to do a belts and suspenders thing and then have every possible insurance policy in place that I can. I want to cable and zone the 9000 to the legacy storage as a host. I also want to have the ability also that I can also pre-zone the 9000 to the server as well. At some point in time, I have to disconnect the server because I have to change the zoning of the server to point from the legacy storage to point to the 9000. While I'm doing that, I'm probably going to have to do a couple things to the host depending on what the legacy storage is. But there are certain applications, multipath applications like PowerPath, that can take a number of reboots to really fully get rid of. And that's one of the things you want to do. You want to get rid of any multipathing application that's on there because, like XIV, the A9000 uses the built-in multipath of the operating system. I also want to then, step 4, I want to define the migration processes, right, which basically says create a volume on the 9000, and I want to basically map the volumes to the 9000, and I want to create a volume that matches that. And the 9000 will do that automatically as you're creating the migration. It will issue a query down to the legacy storage and get the block size. Because when I do this, I want the volume is created on the 9000 using a block size, so that it's an exact one-to-one reference between between LBA 0 down to LBA N, because again, I'm going to do a one-pass read of the legacy to move that information back up into the 9000. Once I define that process, I can start the migration process. I can bring the host back up, point it to the 9000. It's going to see all the volumes that it's on the legacy storage, and then I can run I/O from the server to the 9000, and again, it will proxy reads down to the legacy storage if it doesn't have the information. Once I'm done and I've moved the information and I get the status that the migration is complete, I'm going to go ahead and delete the migration relationship. And then I can repurpose the legacy storage. I can, shred the drives. I can give it to test dev, whatever's appropriate at that point in time. So the only time I take an outage is when I'm moving the server from pointing at the legacy storage to pointing to the A9000. At the tail end, I don't have to take another outage because I just essentially delete that relationship, and I/O continues to run from the server to the 9000. And again, I can do this with pretty much any storage out there that will talk to a Linux host. And I've not tried this with a 9000, but we had some issues with EqualLogic and how they do IP spoofing in the EqualLogic that created some issues with doing a migration from EqualLogic. That is the only box I have heard that there's trouble with doing a migration, because essentially the 9000 is behaving as a Linux host. The other thing is we typically don't do this with VMware with data stores. It's a little more time consuming, but I think it's simpler from execution perspective to just do a storage vMotion. And the other thing we typically don't use this for is with SVC. We use image mode migration from SVC to move data between volumes on if SVC is in there. So again, this is really typically only used for legacy storage to A9000, and again, not in a VMware or an SVC environment. Again, I'm going to connect it from port 4 down to the legacy. I don't, in this case, connect back from the storage to the A9000. I don't have to do that. Right, that connection's there from a replication purpose for fail-over cases. I don't ever plan to fail over here. So initiator to target is fine in this case. All right, and what I'm going to do is I'm going to, if I set up 20 volumes, I'm going to actually migrate one volume at a time, but I can have production running on all those volumes because, again, for any volume that has a defined migration relationship, the A9000 will proxy reads down to the legacy storage so production can run, but it's actually only going to be doing that one pass copy one volume at a time. And again, we can set that rate and tune that rate so I could have it slower during the day if there's production workload running on that legacy storage, and I can change it at night to go faster at night so I can pull more data faster because, again, I'm not as worried about the load on the production, the old production box, the legacy box, because I know it's not busy. And it says here 100 megabit second is defaultly recommended. Depending on the legacy storage, you may want to actually drop that a little bit. Depends on how capable it is. I kind of like to start at 50, and it's not hard to bump it up, and after I've made sure I'm not affecting the production storage, it's really hard to recover from, oh, what did you do to my production? Everything is slower now. So I kind of err on the side of caution and start low and work my way up. Again, defining a migration process, here's my target LUN. I can use an existing volume. I can create a volume. I always suggest creating a volume because that means the A9000 is going to go and read that volume and create the volume with the exact right block count. You can do it manually, but why if the box is going to do it for you? Again, I can do this with up to 10 targets, 512 volumes for targets for a maximum of over 5,000 volumes concurrently being migrated. Again, I'm only going to do one at a time per target. So at most, I will have 10 volumes being actively migrated, but I can have lots and lots of volumes kind of in the queue waiting for their turn, and I can be running production on all of those volumes because I will be then proxying reads down to the legacy storage. So hyperscale mobility is what I call a special case of data migration. It is currently only for A9000 to A9000. I say that very specifically. That is a pod to a pod. Hyperscale mobility is currently not supported for A9000. However, if you have a need for this, please bubble that up to your to Jim and his team, and I will help him get the information to the right people, so we should be able to do this via RPQ. So I'm seeing, Karen, are you seeing something different on the? I'm seeing Brocade.
Oh yeah, Charles Gordon, what did you hit?
All right, hang on a second.
Okay, you got to reshare.
Did I get the right one? You were seeing the blank hyperscale mobility? All right.
I see it, yep.
So again, it's only supported between 9000s now, but if you have a customer that needs it between a 9000 and 9000R, between 9000R, please bubble that up to me through Jim's team, and we will put a little more pressure on the dev team to get us that support. It's coming. It's in the roadmap. It can't get here fast enough as far as I'm concerned, and every time we have a customer ask for it, I need to get the offering management team and the development team to hear that. So please, if you've got those requests, please let me know, and I will pass those on to the appropriate people who need to do the appropriate work. What it allows us to do is move a volume from A9000 to A9000 without taking an application outage. I essentially do this by spoofing multipathing. And so it allows me, it's by manipulating multipath to move that volume, and I'll show you how we do that. So I start my hyperscale mobility, and what happens is frame A moves starts to move the data to frame B. All right, and after that is migrated from the source of the nation. The volume can be moved into proxy mode, and it's a manual step. So once I've created the mobility relationship and I get to where I've moved the data, I get to where I'm proxy ready, I can then go to proxy mode. What happens at that point in time is even though the host is accessing the volume through the first frame, that frame is proxying all of the commands to the second frame. So the only thing that lives on the first frame at this point in time when I'm in proxy mode is essentially, I'll call it a metadata header that allows the host to think that volume still exists along those paths. Then what I can do at that point in time is add multiple paths to the new 9000. I do that through if it doesn't happen automatically, which it does sometimes, I can issue a hack command to rescan the bus to pick up the new path. And then once I'm assured that I've got new paths, then I can unmap that volume from the first first A9000 from the host, and the host is now only, again, I can either force a rescan or allow the multipathing and it won't find the bad paths, but you probably want to do a rescan to force the fact that those paths are even no longer there once I do the unmap to kind of clean things up. So without having to stop the application, I've moved a volume from one 9000 to the other without taking the application down. Again, this is only available between 9000s now. That's not, I mean, I can also do it between XIVs, but I don't have any cross-family interoperability on hyperscale mobility. That is a roadmap item. It is coming later this year, but currently right now, I can only do A9000 to A9000 or XIV to XIV. Technically, I can also do between Spectrum Accelerate instances as well, and that actually uses iSCSI. So I do have at one place, part of the family, I've got the code to do on iSCSI hyperscale mobility, but currently I only support fiber channel on the A9000. And again, I'm hoping in the future that I will get the ability to use iSCSI as well, but that's another future support item. So again,
so even
go ahead.
So one question, even the A9000 to XIV is not allowed either?
Correct.
Okay, thanks.
So the plan is to have that in the 12.2 code, which is out later this year. So again, phase 1 migration, I'm doing synchronous mirroring to move the data between from the source to the destination. Once I do that, I'm in proxy mode or proxy, right, and then all the application I/O is being proxied by the primary box or the secondary box. I add paths at that point in time, right, and then I can see it through both, but I'm really, even though I'm seeing it through both, the host believes it's seeing it through one A9000 through just additional paths. And I can unmap that source and rescan the bus, and now I'm back to running only on one A9000. So I do require the multipath driver because again, I'm futzing with multipathing. Without the multipath driver running properly on the host, this will not work. I do have to have the zoning in place for the host to have paths to both A9000s. And I have to have two A9000s connected via fiber channel for this to work. And two things to look at, right? Excuse me. Not only do I have the capacity on that A9000, I have to have the ability to support the performance requirements. So as you're doing migrations, you want to make sure that you're looking at the response time of that 9000 and making sure that it's not starting to climb because of the workload we've had and has hit a knee in the curve. Not as worried about that with the 9000 as I am with the XIV, but still, any system, and it's, again, we're talking about the pods only. So this is the 3-grid controller, one FS900 config. It's not the big rack config yet. So it is what I call the smallest of the 9000. So yeah, if I'm migrating a bunch of stuff, because again, I can do data reduction here and get some pretty good data reduction rates. Just because I have the capacity for it doesn't necessarily mean I have the performance for it. And you gotta take both aspects into consideration in order to be successful with the migration. Because the last thing you want to do is move off of old storage on a new storage and have the new storage be slower because you just overloaded it and just can't deal with the workload. Again, I'm going to volume migrate one at a time, first in, first out. If I'm in a mirroring relationship, wow, easy for me to say, a mirroring relationship or in a consistency group, I cannot move them. If the volume has snapshots, I can do a mobility, but I'm not going to move the snapshots. I'm only going to move the volume. So if the customer is using their snapshots and wants to keep a number of snapshots around for a while, I have the ability to not delete the snaps when I do this, but that means sometime later I've got to go and back and delete those snaps so they don't continue to take up space. And as always, right, practice on a non-production volume first, making sure that either through native OS commands or through the host attached kit commands, you have the ability to, see new paths and have the old paths go away so the multipath driver is not trying to send I/O down paths that won't work. Because eventually it will get to a path that will work, but that's going to add potentially add latency to the transaction because of the recovery time on each failed attempt. And that is it. Are there questions? Wow, with a whole 4 minutes to spare.
You did good.
Any questions? All right. I think we're done, Karen.
We are. I hope everybody joins us tomorrow for our last session of the 4. I believe it's 3 p.m. Eastern tomorrow. Thanks, everyone.